Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of volume. This is standard 7.9a in the great state of Texas, and we are using item number 14 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've been working with volume of cubes and volume of rectangular prisms ever since the 5th grade. But now we have a triangular prism, and looks kind of like a long tent, camping tent. And what you're going to find is that the equation for prism is pretty simple. It's base times height, and it just says prism, any type of prism. So this is a triangular prism. Prism is simply a three-dimensional shape, and it's got two sides that are the same, and just imagine that they're kind of stretched out. So this is a triangular prism because you have two triangular bases and they're kind of stretched out. You can have a rectangular prism, you can have a hexagonal prism, an octagonal prism. You can have all kinds of prisms as long as you get two bases that are hexagons, squares, rectangles. They're both octagons, decagons, and you just stretch them out, and then you've got some rectangles connecting the two faces. And so we just need to find two things: base times height. Now this base, that's where it gets a little bit tricky right here. So if we were to stand this up on its end, right, we could say we've got a whole bunch of different numbers here, 1, 2, 3, 4. We don't need one of these numbers. What we need here is we're going to use this height is between the two bases. So here are our two bases, right? And you see these are the three rectangles that are connecting our two bases. And what's the distance between those two bases? That's 16. So it's going to be base times 16. That's our height. So the reason why we can have such a generic equation is because every prism has a different equation for finding base. So if we were going to do a rectangular prism, kind of like this, like let's draw some rectangles and just pretend like we're going to do this. Well, then that base is pretty simple, right? That's length times width. And you could say length times width times height, or base times height, because base would be this length times width. Triangle, we don't use length times width. So what we have to know is how to find the area of this base. So this is the base we're looking at right here. We need to find the area of a triangle. So it's kind of an area problem wrapped up into a volume problem. So the base equals the area of, I'm going to put a little t right here, a triangle. So what is the area of a triangle? Well, area of a triangle is 1/2 base times height. And if for some reason you ever forget that, think of the very first thing you learned about area, and that was with a square or a rectangle, right? And it was length times width, or base times height, if you want to really call it that way. And think about, if you take a triangle, you cut it in half. You take this diagonal line, you can take any square or rectangle, turn it into a triangle, which means the area is half of it. So that's 1/2 right there, and that's the other half. So that's why 1/2 base times height works, because it's the half of the area of a square or rectangle. And so what is my base? Well, my base is right here, 6 centimeters. What's my height? Right here, it's this 4, and it's a dotted line here because you're not going to use the side of a triangle, which means this is an extra piece of information. You only use the side of a triangle when you have a right triangle, and you can use that. But the height sometimes will be this dotted line in the middle because it's kind of imaginary, because it's not really there. It's not part of the triangle. So you've got 6 times 4 is 24, so half of 24, that equals 12. Now we got to bring this all the way back here. So prism is going to equal that 12 times 16, because my base is 16, and that is going to equal 192 centimeters cubed, G.